Okay, so this is the video for the Unit 9 review handout. I'm just going to do page 1 in this video because if I try to do it all, it'd be an hour-long video probably. All right, so in the first problem, we're supposed to match up various arcs and points and things like that with the terms that go with them for circles. And let's see, if more than one term can apply, pick the most descriptive one. So like if you had a diameter, you'd want to call it a diameter instead of a chord. Now in this problem, H is supposed to be the center of the circle. So, okay. So let's see, arc AC, you should be able to know just by seeing only two letters that that's got to be a minor arc. And if you look at the picture, it's definitely less than 180 degrees. So AC is a minor arc. Minor, whoops. ADC, so if we start at A and then go around to D and then keep going until you get to C, this whole arc right here is going to be a major arc. And AED, let me get rid of all this. If you look at A to E to D, start at A, go to E, keep going till you get to D. That looks, that's a semicircle because this is a diameter right there. So this is 180 degrees. So that'll be a semicircle. Let's see, point E. Where's point E? Here's E. Notice that there's this tangent right here. So point E is going to be the point of tangency. H, whoops, let me get rid of this. H is right in the center of our circle, so that's the center point. Looks like it says center point. Center point. Line BG. Where's BG? Here's BG. So notice that goes right through the circle. Cuts it twice in two places. So that one is a secant. Remember, SEC means to cut. So this one's a secant. There we go. EG is this one. That only hits the circle at one point, so it just touches. So it's a tangent. Why is this pen not writing? There we go. Let me get rid of all this junk. Okay, hold on. Okay. Angle DGE. Let's see. That is this angle right here. Well, notice the vertex is outside the circle, so that one is the outside angle, right? Which isn't really a formal term, but it helps you remember which of the formulas to use to calculate how big it is. Remember, that's 1/2 big minus little, outside angle. Angle ADE. Let's see, here's A to D to E. So that angle, the corner is right on the circle, so that's an inscribed angle. And that is a normal term for it. AFD, that's right here. AFD, well that one, the corner is inside the circle, but not at the center. So that one we've been calling inside angle. And AHD, that's this angle right here. Well, you know, it's 180 degrees, it's a straight angle, but it's also the corner of it, the vertex of it is at the center of the circle, so it's a central angle. Let's see, segment AC, that's right here. Endpoints are on the circle, so that makes it a chord. Segment AD, that's right here. Its endpoints are also on the circle, so that makes it a chord, but because it goes through the center, the better term is going to be diameter. Segment HD, so that's from center to point on the circle, so that's a radius. And personal growth in an atmosphere of wise freedom, that is goal 5. All right. Let's take a look at number 2. So this is a rotation problem. And they give you point L here is at -9.5. They give you the center point is -4.2. And we're trying to figure out these 3 other points on the circle. So before we jump right into that, let's make a slope triangle. Because since they're 90-degree rotations, we can use slopes for perpendicular lines to figure out all this stuff. So when I move across left to right, the axis change, I went from -9 to -4. So that's 5 units across. And when I move up and down, the y's change from 5 to 2, so that's 3 down. So if I connected from A to E, notice that's 180 degrees, so that's a straight line from L to E. So I could just repeat my slope, right? It's another 5 across and 3 down. And if I'm at -4.2 and I go 5 units to the right, the x is increased by 5, so -4 plus 5 is 1. And then if I drop 3 from the point 2, then I'm going to be at -1. Okay, so notice these slopes right here, this slope is -3/5, and this one's going to be the same thing, -3/5. Well, when I draw in these other radii, so I'll draw one in here, and one in here. What we know is since these rotations are all 90 degrees, this central angle right here is 90, this one's 90, this one's 90, that one's 90. And I know that the slope of these perpendicular radii are going to have to be 5/3 because that's the negative reciprocal of -3/5. So now what I'll do is I'll draw in some slope triangles for the 2 blue radii. So here's one. And here's one. And remember the slope is now 5/3, so it's up 5/3, or down 5 and backwards 3. And so if I start at that -4.2 and I go up 5, the y is increased by 5. So if I increase the y's by 5, it's 7. And if I go to the right 3 units from -4, the x turns into -1. So I'm at -1.7 for R. Where else am I? I'm at -1 for E. And then to get K, well, remember this point right here is -4.2. So if I drop 5, the y's change by 5 and they go downwards by 5, so that'll be -3. And if I go to the left 3, the x's decrease by 3, so -4 take away 3 more, I'm at -7. Okay, so I'll make another video for the other pages.